Alright guys, so yesterday we talked about least common multiple. And remember we defined least as being small, tiny, minuscule, all those words, okay? Well today we're going to change least. And we're going to change it to the word greatest. Ali said, I am the greatest. Alright? So when you hear the word greatest, what are you thinking? Alright? And we talked about it today. So bigger, biggest, giant, huge, largest. So I got some great words for greatest today. And then when we talked about multiple, remember yesterday we said multiple is hashtag times hashtag. So what we really meant was number times a number. Okay, that's why when we do multiples, they keep getting larger. Okay, well, today we're going to change multiple, and we're going to change it to factor. And that's spelled wrong, so let's fix that. To factor, all right? And factor, and the reason why I say factor, because I wanted to remind you of a divisor, which is the anchor of a fraction, which means we are going to divide. Okay, so now we're going to change our multiplication symbol to a division symbol. So it is a number divided by another number. Right? That's what we're talking about when we say a factor. Now, I do want you to think about one thing real quick. Before we go too far, and I'll go ahead and erase this now. Let's talk about prime numbers. All right? Prime numbers, and I'm not just talking about another transformer. It's a big truck turns into a robot. That's not what I'm saying. I'm talking about a number that is only, and the key word here being only, divisible by itself and the number 1. Okay, that is a prime number. So you can see 1, 2, 3, 5. You cannot divide them by another number and get a whole number as a quotient. All right. Notice there's only one even number, and that's 2. That's because the rest of the even numbers after 2, as we discovered yesterday, are divisible by 2. Alright, so let's talk about greatest common factor. Now, when you're talking about greatest common factor, there's really two methods that people can use. Alright, we can either make a set of factors and work it that way, or we can use what is called a factor tree and work on prime factorization. Okay, so let's do two numbers. The two I used today, and I'm going to use them again now, is 48 and 32. Okay? 48 and 32. So if I'm trying to find the GCF, or the greatest common factor, of 48 and 32, there's a couple of different ways I can do this. Alright? Now, my preferred method, and like I told you guys today, is to do a set of factors. So, I would start over here, and I would start with 48. Let's put a little colon there. And a 32. Put a little colon there. Okay? So, now I'm going to start asking myself, what are the factors or the divisors of 48? What number can I divide 48 by? So I know all numbers are going to have a factorization of 1 and 48. Alright? Because 1 times 48 equals 48. So make sure you give yourself a lot of room here, okay, because we're going to fill in this space. Okay, now the part of the problem with this method is you got to be very methodical. You got to go step by step. So I started here at 1. So now I want to move on to 2. All right? Can I multiply 2 by any number to get 48? Yes, 24. So I'll write 24 over here. All right, now 3. Will 3 go into 48? Well, I know 3 times 6 is 18, so I might be able to get that 8 in my ones column. So 48 divided by 3, that's going to give me 16. So 3 times 16 will give me 48. The next number is 4. All right, it's a 4 and 8, so that should be pretty simple. 4 times 12 is 48. How about 5? Well, it doesn't end, 48 doesn't end in a 0 or a 5, so 5's not going to work. Notice I'm going down the line. How about 6? Yep, 6 will work. 6 times 8 is 48, right? How about 7, right? Because 7 comes in between these two numbers. 7 times 7 is 49, that's over 48, so 7's not going to work, and then I'm at 8. So now I've completed my factor set for the number 48. Now, let's look at 32. So you're going to have 1 and 32. All right, like I said, give yourself some room. All right, now I know that 32 is an even number, so I know 2 is a factor of 32. So 2 times what will give me 32? 16. All right. How about 3? Will 3 go into 32? Well, the 3's there, but no, it's not going in evenly. How about 4? Will 4 go in? 4 times 8. All right. 5 doesn't end in a 5 and a 0, so 5's not going in. How about 6? Maybe, but as you look at it, the closest thing I can get is 6 times 5. That's 30, so that's not going to give it to me. 7, 28 is about as close as I can get. So 8. So this is my factor set for 32. Now, remember that we're going to try to find those commonalities, right? We want to find the common answers. So let's find our common factors of both 48 and 32. So the first one we all know is 1 and 1. Then we have 2 and 2. There's 3 there, no 3 down here. I do have a 4 here, 4 and 4. All right, I work left to right, this is how I do. 8 and 8, and 16 and 60. So now I see that I have 1, 2, 3, 4, 5. 5 common factors of 32 and 48. But what does this say? It wants the greatest common factor of 32 and 48. So which number is the largest? That number is 16. So 16 is the greatest common factor of 48 and 32. Okay? Now this is my preferred method, and I did this today, so I'll show you guys again here. Okay? And if you're struggling to figure out what I did here and how this works, so it's 1 times 48, and 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So you can even make a little multiplication symbol there to show that those are the numbers that I'm multiplying, and they all give me a product of 48. And down here, the same thing, 1 and 32, 2 and 16, 4 and 8, and I can put my little multiplication, if that helps you. Okay? And that shows how we got those factors of 32. And our greatest common factor is 16. Now, moving on. Now, I told you that is the first method, but there's also another method. All right? Another method, and it's the factor tree. Okay? And to properly use the factor tree, I want you guys to ask yourself one question. Is this number prime? 48 is not prime. Okay? So, if it's not prime, then I'm going to add my branches of the tree underneath of it. Okay? That's why they call it a factor tree. Okay? So, I'm going to add my branches down underneath of it. And 48, I'm thinking, first thing coming to my mind is 6 and 8. All right? 6 times 8 equals 48. Okay? Now, I come to the number 6. Is the number 6 prime? Looking back over here, it's an even number, right? And I said the only even prime was 2, so I'm going to add my branches here. Now, what times what to give me 6? Well, 1 times 6, but that won't help me none here, but 2 times 3 will. So 2 and 3. Over here I have 8, so is 8 prime? No. So I'm going to add my branches. All right, and that's going to give me 2 and 4. All right, is 2 prime? No. I mean, yes, it is. Is 4 prime? No. So I'm going to add branches underneath of that, and 2 and 2. Now, be careful, guys. I'm telling you right now, be very organized when you do this. Because at the end, when you're trying to find your common factors, this can get very, very confusing. So watch how you put your factors down. This is what we call prime factorization. So that's it. We did our prime factorization of 48. We're down to all prime numbers, no more branches on the tree. So let's go to 32. So is 32 prime? It's an even number, so no. All right. Now I did it a while ago, but I'm just thinking 4 and 8. All right. That's a very common answer for factors of 32. 4 and 8. 4 times 8 is 32. Now, is 4 prime? No. So I'm going to break it down. 2 times 2. All right. Is 8 prime? No. So I'm going to add some branches, and that'll give me 2 and 4. All right. Prime number, prime number, prime number. Is 4 prime? Nope. I'm going to add some branches to 4. And then that gets me down to 2 and 2. And now I'm prime for 32. Now, when you're going back and you're trying to figure this out, I want you to go back, guys, and we were having some issues with this. All right. I want you to go back, and I want you to draw a line that connects all your prime factors underneath of them. So come over, step down, and underneath, okay? Those are all my prime factors. Those are my prime factors of 48 and my prime factors of 32. Now, what we're going to do is, all right, we need to find the common, the same. So, like I said, left to right, so we'll start over here on 48. So I have a 2 here. Do I have another 2 over here? Yes, I do. Now, this is very critical, guys. Make sure you are doing this. All right? Make sure you're doing this. Cross it out. Cross it out. Reason being, you may forget that you already counted that one. And I'm going to take that 2, and I'm going to put it right here. Okay? So my next number is 3. Do I have a 3 over here? I have nothing but 2's, so 3 I can't use. Okay? How about this 2 here? Alright? I've got a 2 here. Do I have a 2 over here? Yes, I do. So now I can cross that out, cross it out, and then I'll take this 2 and bring it up here. So I crossed out another 2. Alright? So then I come to another 2. Do I have another 2 over here? Yes, I do. And I'm going to continue crossing out these 2's, right? Now, once I cross them out, I got to remember, I have to bring them up here. So I crossed out 2 2's, and I'm going to bring both of them up here. So 1, 2, 3, 4. I crossed out 4. 1, 2, 3, 4. Checking my work. I'm good. This 3's left. That 2's left. Don't worry about that for now. We're going to come up here, and now I have 2, 2, 2, and 2. Once you do that, this is an important step. We're going to multiply. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. All right? And that, folks, is how we find the greatest common factor using the factor tree method. Okay? Work on this, guys. Remember, with factors, you're going smaller, not bigger. All right? And this works out great for when we're simplifying fractions. All right? I told you guys today, know how you can use this to your advantage and know your number sense. All right? So that's greatest common factor. Good luck on the homework tonight. The tutorial already got done, and I'll have it uploaded.